Dr. P. Nagaraj. He is currently working as Assistant Professor in the Department of Chemistry, Anna University, Chennai. Earlier, he worked as a scientist in charge at Spices Board of India for 5 years in research and development and also in quality control laboratory. He has finished his PhD in organic chemistry at IIT Delhi. He has also done his MSc Chemical Science at Pondicherry Central University. He has published 6 papers in international journal and also participated several international events in India and abroad. He has attended several conferences and delivered lecture as keynote speaker and also undergone 12 training programs. His area of research interests are isolation, synthesis of natural products and evaluation of their biological activities, carbohydrate-based natural product synthesis, enzyme catalyst organic synthesis, green chemistry, medicinal aspects of spices and spice products.
Welcome to UGC lecture series. Today we are going to discuss about synthetic fibers and its applications. There are few synthetic special fibers material, how it is synthesized, what is the special property of the material, that we will study today class. Content of the today lecture is synthetic fibers, types of synthetic fibers, examples of synthetic fibers. There are few examples we will discuss in the details. Properties of synthetic fibers, how it is manufactured of synthetic fibers and applications. So, this we will see in today class. Before we start fiber or fabric, we will find what is monomer and polymer. A substance are made of units, any substance which is made up of small units. A substance having a single unit structure forming its particle called monomer. A certain substance thousands of units joined together to form a large unit called polymer. Poly means many. Polymer is made up of many repeating unit of monomers. The process of joining together monomers to form a polymer is called polymerization. So, this is basics we should know before, and we will study synthesis of synthetic polymers or fabrics or fibers. We should know what is monomer, what is polymer, what is polymerization. And another thing is there are two types. One is natural polymers. Natural fibers like a cotton, wool and silk are polymers or fiber material. Cotton is a polymer. Glucose is the monomer which is present in cotton or fiber material. Wool and silk are the polymers of amino acids. Why? Because animals which is made up of mostly proteins, which is made up of again amino acids. The monomer which is amino acid, which will give the polymers like a proteins. Spider silk is one of the strongest natural polymer. So, that is one natural one, and out of that we can see some synthetic polymers. Synthetic polymers are made from chemical substances, they are plastic in nature. So, synthetic fibers are made from some synthetic chemicals. Nylon and polyesters are examples of synthetic fibers. So, here some examples shown here. Ethylene is a monomer obtained from petroleum as a byproduct. It is a chemical formula CH2 which will repeating unit. During the polymerization, many units of ethylene gets linked to form a chain as follows. So, you can see the picture like one of the monomer unit, another monomer unit which is linked together to make a polymer which is called, since the monomer is ethylene, the polymer which is polyethylene. This polymer is polyethylene, a kind of plastic polyethylene. So, which is material nature is like a plastic material. And another one example here, some polymers are made up of 2 or more units, 2 different units here which is the same unit, in case of here 2 different units. Example nylon which is made up of amine and adipic acids. So, here one is a different monomer, another one is a different monomer, combined together will give a polymer. Next we will see raw material for synthetic polymers. Synthetic polymers, scientists evolved a mechanism to polymerize the monomers of certain substances like rubber, silicone and petroleum products such as ethane, propane, benzene, toluene, styrene, ester and others. So, these are all the compounds or chemical molecules. All these are raw materials for synthetic plastics. So, whatever you want to make any synthetic materials or polymers or fibers, so these are all the starting material to be taken. In the East, including India, cotton, wool and silk, and in the West it was leather, wool and fur. which were the first material to be used for clothings. So, we used to take clothings, normally cotton, which is in India widely used. So, somewhere the people use leather and wool also. Other natural fibers were also being used in different parts of the country depending upon their availability. Whatever the material available, they will use it as a clothing material. It was towards 1930s that the scientist synthetic fibers was developed. Before that, only naturally available fiber or fabric material which is widely used for dressing as well as clothing purpose. So, 1930 is the time where the synthetic material comes out. Most synthetic fibers are obtained from petroleum products. As we discussed earlier, petroleum product will use one of the raw material, natural gas and coal by the process of polymerization. Use any one of the raw material, you can undergo polymerization, which can give polymeric product. Synthetic fibers, the polymers for synthetic fibers are synthesized or made from small simple molecules, not naturally occurring. So, synthetic fiber, it should not be naturally occurring. So, via chemical you can make a polymerization, you can produce fiber material. Often petroleum based chemicals, also known as petrochemicals, using complex procedures less than 1% of total use per year. So, if you want to make a synthetic fibers material, you can use chemicals or you can use petrochemicals to make fiber materials. Different chemical compounds used to produce nylon, polyester, olefin and acrylic. So, these are the representative example that we will see all the properties and the synthesis of those materials. Synthetic fibers common properties. So, one of the property is heat sensitivity. Fibers that soften or melt with the heat differ in their level of sensitivity, use care washings, ironings and dry cleaning. So, heat one of the parameter, if you heat it any fiber material, synthetic fiber or natural fiber, it will get elasticity or it will get soft or it will get melt. And chemical resistance, fibers do not absorb water, solvents, acids or bases, resist soiling, difficult to dye. So, this is the peculiar property, it will not absorb any water molecules or something. Most of the synthetic fiber materials, it is very difficult to make a dye, it have to absorb water, then only it is easy to dye the materials. Another property is spilling, formation of tiny balls. So, it can make a tiny balls, tangled fiber ends on fabric surface due to abrasions. Strength of fibers keeps balls from falling off naturally. It is a natural process, the pilling one, which can increase the strength of the fabric or fiber material. Synthetic fiber, again another property is static electricity generated by friction. If you wear the synthetic material while doing the friction, it can generate electricity. More rapid in cold, dry regions, attract dust, soil and lint brushing to remove increases problem. So, it can easily absorb dust particles, all these things. So, it is very difficult to remove also. Another one is oleophilic, oleo means oil loving, philic means loving. So, it is a high affinity towards oils and greases. So, synthetic fiber, which is mostly synthetic material, which is easily dissolve oils or grease, which have hydrophobic in nature, it will not absorb water, but it is highly absorb oils and greases. So, this picture is representative for manufacturing process of melt spinning. So, the molten polymer which is supplied here in this portion where meter pump drive, meter pump unit, filter pack and spin crate, air quench chimney. So, all these setup, the molten ware passed through here, convergence guide, interflow tube where it can be come out and feed rolls, low speed tube wind up and high speed tube wind up where it can be go through like this, well it can be collected. So, draw zone, ring and travel wind up spin. So, what after finishing all the formalities, this will come and it is wind up here like this. So, common manufacturing process which involves drawing, one of the method, aligns molecules in more parallel crystalline oriented arrangement, drawn to develop desirable strength, pliability, toughness, elasticity. So, manufacturing process, one is drawing, which means the how you are closely bringing the fibric or fabric material, that will based on your what kind of strength you need or toughness. Based on that you have to make. This is one of the method which will give oriented arrangements, and it will give desirable strength and pliability, toughness, elasticity, etc. And another one method is a heat setting, uses heat to stabilize the shape and dimensions of yarns or fabric. After cooling fabric yarn, stable at heat lower that at which it was set. So, means using heat you can make it, and after making whatever way or shape you can make, after that you can cool it, you will get back the fabric materials. And another thing is identifications. So, as we discussed in the previous class, we can go for burn test, like I used to identify presence of some are not good for blends of or fibers that are flame retardant or heat resistant, does not identify specifics. So, some of the fibers are flame retardant, which means it will not burn easily, like which is used in aircraft and railway compartment and all, that material may not be easily flammable. And we can also go for microscopic test, appearance not reliable because so easily modified, and solubility test only procedure that differentiate among synthetics. So, if you do the solubility, some of the polymer or fibers which can soluble specific chemicals, based on that also you can identify. And common modifications, fiber shape and size. Because of melt spinning process, changing cross sectional shape is relatively easy. Spinnerlet hole. Halo fibers provide better thermal properties and lighter weight, hide soil. Trilobal, pentalobal, multilobal fibers used in apparel and interiors, and flat ribbon fibers used in form valver, and channels fibers used in activewear. So, different type of fibers used in different kind of applications. And the common modification again, low pilling fibers engineered to minimize pill formations, decreases fibers flux life, and high tenacity fibers produced by combining drawing with the molecular chain length modifications to ropes, airbags, parachute cords, etc. Low elongation fibers, stretchless under force. So, low elongation means it should not elongate or it should not expand. So, during the stress force, but as strong as regular fibers, apparel interior items that receives hard use, work apparel and heavy duty upholstery. So, wherever we need, based on the application we can make it like different types of fibers. Example one is nylon, the first synthetic fiber 1939, that is more than 100 years back, by DuPont, which is a Japanese based company, introduced to public in women's hosiery. Unlike any fiber in use at the time, stronger, more abrasion resistant, excellent elasticity, heat set, lightweight, chemical resistance. So, these are the peculiar property of nylon, and also had drawbacks like it is static buildup, poor hand, poor comfort on skin, low resistant to sunlight. So, these are all the drawback of nylon. Again, nylon which is production made from various substances, like number after name indicates that carbon atoms in starting material nylon 6,6, adipic acid and hexamethylene diamine, which is widely used as a starting material. Physical structures available in multifilament, monofilament, staple in variety of length, and tow in a wide range of tenures, shapes as a partially drawn or completely finished filaments, produced in bright, semi-dull and dull lusters with varying degrees of strength. And nylon again aesthetics, which looks like a smooth, lightweight, high strength, can be lustrous, semi-lustrous or dull, varied drap depending upon use, wides and flat sides scatter light and hide soils. So, it will not absorb any soil material. And durability, outstanding durability, excellent strength and high elongations, excellent abrasion resistance. So, which is have very long life. And comfort, not as comfortable to wear as a natural fibers, because synthetic have this kind of problems. great for wind and water resistant jackets. So, we can use it for water or wind resistant. For cold we can use it, or if you go out in the rain you can use as a material. Again, nylon appearance retentions, high resilient due to heat settings, pleats, greases and embossed designs become integral. Comparison resiliency important in carpets. Shrinkage resistance high due to heat set, low absorbency. So, it will not get shrinkage as like natural fibers materials, it have some other good applications. How we can care it? Hot water may cause permanent wrinkling, but can help remove oily stains. So, we should not use hot water. And a color scavenger, if you use any color material then there is a problem to make it, and dries quickly, resistant to mildew, insects, fungi, low sunlight resistance is a very important properties. It is resistant to fungus attack. Fungus can easily form in natural fiber, whereas in this kind of synthetic fabric it will not attack any kind of fungus or microorganism. Again, environmental concerns, sustainability, all concerns associated with the petrochemicals made from byproducts, which is again called as a waste. Production consumes more energy than the polyester or cotton, and nitrous oxide is emitted from the production of facilities. So, synthesis in these are all the problems, and the processing uses a few cleaning chemicals, less water, salt and acid used for dyeing, recycling reasonable, carpet recycled to a nylon 6, raw material are mixed with the plastic or concrete, performance enhances additive process challenges. So, which can be after uses this material, which can be used as additive for making this kind of applications, which is environmental concerns. Again, reclaimed carpet, type 6 nylon and new nylon fibers. So, which is again you can see the shape which can differ. Through SAS national system, post consumer carpet is collected and sorted according to fiber types. The type nylon 6 carpet are sent to evergreen nylon recycling, where they are sorted into small pieces and converted to mixing melting units. So, like this after using we can make it for recycling. Another type 6 nylon, the post consumer carpet fiber is recycled and converted into carpet lactum. The building block of type 6 nylon, which is lactum. The caprolactam is purified through a series of operations and transported into facility where it is converted into type 6 nylon polymer, which is again the product which is obtained from caprolactam. New nylon fibers, Anso nylon and Eco solutions. Nylon fiber contain type 6 nylon recycled from evergreen. They can then be tuffed into new carpet. These fibers may be recycled repeatedly without the loss of any aesthetic or performance properties. So, which can be used in recycling purpose. And nylon where it is used is lingeries, hosieries, socks, sporting goods, tents, sleeping bags, and average car uses 25 lbs of fibers, upholstery, carpet, headliners, doors and visor trims, umbrellas, cloth lines, toothbrush, hairbrush, luggage, backpack, and another class of fiber material which is polyester, first produced in England, introduced in US 1951, almost 60 years back by DuPont company, again Japanese company, most widely used synthetic workhorse. Filament extremely versatile, while staple can be blended with many other fibers. Versatility in blending is unique advantages in case of polyester. Produced by reacting dicarboxylic acid with dihydric alcohols, fibers are melt spun and hot drawn. So, polyester nothing but acid alcohol will produce ester, which is polymeric form will give polyester. Produced in many types like filaments, high or regular tenacity, bright or delustrated, white or solutions dyed, regular or low pilling. Generally smooth rod like fibers with circular cross sections. So, you can see this kind of smooth fiber can produce. Other cross sections like trilobal, octalobal, oval, halo, voided, hexalobal, pentalobal, star shaped, etc. Properties of polyester, again aesthetic property, which is blend well, maintaining natural fiber look and texture. Microfibers particularly suited to high fashion because of versatility and durability. Again durability, which is excellent abrasion resistant and strength, better sunlight resistant, which is very important. If it is undergo degradation in case of sunlight or environmental condition, which may not be suitable, which is environmentally stable. And comfort, poor absorbency lowers comfort factor, finishes and fibers modification increases comfort. So, it may not be comfort like a natural fiber material, all synthetic fiber material may not be comfort. And appearance, retentions, generally wrinkle resistance except when set by body heat and moistures. So, it may not be wrinkles like natural or fiber materials. Care, how we can care? Wash warm, machine dry medium heat and remove promptly, hang, touch up with steam. So, this way we can care it. Polyester environmental concern is similar to nylon, petrochemicals, which is obtained from petrochemicals. Production energy less than nylon, more than cotton. So, which is widely used, we already discussed in the previous class. Uses small amount of water during productions. Uses toxic catalytic agents that contaminate soil, water, long term environmental impact. Extensively recycled, creates significantly less pollutions than the creating virgin fibers. So, which produce again environmental concern, especially catalytic point of view in the productions. Polyester uses most widely used in MF in US, woven fabrics in apparel interiors, knitted fabrics, fiber fill. Non-woven are fiber web fabrics, tire cord and carpets. These are all the applications where polyester widely used. And technical hoses, belts, artificial arteries, veins and hearts. So, these are all the important biomedical applications where polyester used as one of the important compound. Another class of synthetic fiber is olefin. By 1957, Italy was produced olefin, US in 1960. Has a combination of properties that makes good for interiors, apparel that does not need ironing or technical use. Production of this olefinic fiber material, two process, high pressure and film molded materials, low pressures, textile use. So, melt spoon into water or cool air, cold drawn to 6 times its spoon length, crystallizes very rapidly. So, very simple method to make olefin fiber materials. Gel spinning, dissolved polyethylene forms viscous gel in solvent, produces very high strength fibers. The physical structure which is produced as monofilament, multifilament, stapled fiber, tow and silt are fibrillated film yarns. Fibers are colorless, often round in cross sections, have slightly waxy feel, cross section modified according to end use, wherever how we need, that way we can do the modification. Aesthetics, appearance, usually produced with medium luster, smooth texture, many size available, waxy hand, trap varied according to end use. Durability, again produced with different strength according to end use, very durable and strong, lightweight, excellent resistant to chemicals. So, most of the synthetic fiber material are very long durability and have very good strength, which is against microorganism, which is more stable, and some of them are stable against chemicals also. Comfort may not be like comfort like natural fiber material, non absorbent, excellent winking, good heat retentions. So, it may be used as a winter cloth. Appearance, retentions, excellent resiliency and recovers quickly from wrinkling. How we can do the care is easy care, characteristics suitable for number of end users, dry quickly, dry cleaning not recommended due to solvents. If you use any chemical solvent, it may not suitable for this. Waterborne stain, no problem, and does not pick up color. So, if you use any color, it will not get it. Oil stains are extremely difficult to remove because which is oil soluble. So, the solubility very high, it will not be removed easily. Excess heat causes fiber to shrink, melt. If you heat further, it can shrink or it can break down. Excellent resistant to acids, alkali, insects and microorganisms, which we already discussed in the previous. So, olefin again environmental concerns and sustainability similar to nylon, petrochemicals, easier to recycle than most fibers, used in packaging material. So, which can be easily reused or recycled, seldom dyed, used in many products that protect environment, erosion control fabrics, weed barrier fabrics, protective covers for vegetable and flowers, hazardous waste transport container lines. So, again uses apparel, underwear, socks, sweaters, glove liners, hosieries, saris, swimwear, wind, water and cold barriers in active, outdoor wears, thinsulate like a heat resistant or cold resistant. If you want, you can make it as a insulator. Interior textiles, carpeting, upholstery, draperiers, slip covers, almost completely replaced jute as a carpet packing, non-woven fabric, furniture webbing and mattress covers. So, we can use as additive in all these kind of applications. Technical geotextiles, roadbed support, stabilizer fabrics, car, boat interiors, boat. And the final one, which is acrylic, first made in Germany 1893, marketed frequently as being wool like. So, protection, some dry or solvent spoon, other wet spoon. Physical structure, cross sectional shape varies according to spinning method. And aesthetics, attractive and have soft pleasant hand, bulky spoon. Yarns are usually textured to be wool like, matte, luster, almost always staple fiber. Durability, not as durable as nylon. So, the durability is less, polyester or olefin. So, out of all the three, this is least durable. Satisfactory for apparel and interiors, withstand reasonable abrasions, pilling can be noticeable. Comfort, moderately comfortable because of irregular surface, low absorbency, lightweight, wicks well. So, which is comfortable like almost very not much comfortable like natural fibers, but compared to these three, which can be comfortable better than these all previously discussed synthetic fibers. Appearance retentions, moderate resiliency and recovery from bending, resist wrinkling, shrink when exposed to high temperature and steam, cannot be heat set, and solution dyed colors are permanent. So, the dye whatever may be we are using, it is going to stick permanently. What are the care we have to be do? Especially important to follow care label instructions with acrylic. Care varies due to modification or blends. Again environmental concerns, resistant to natural source of degradations, so it may not be biodegradable. Productions of chemical requires significant processing, and recycling of solvents used in spinning is necessary to minimize environmental impact. Wet spoon require washing and drying to remove chemicals, used more energy and water than polyester, so which is required high energy, not recycled. And again uses is relatively minor fibers in terms of use, mostly apparel, some interiors and technical, these kind of major applications for this acrylic uses. Fleece fabrics, sweaters, socks, pile fabrics and fox furs, craft yarns, upholstery fabrics, drapery fabrics, blankets, carpets and rugs, awning, traps, luggage, boat covers, outdoor furniture, tents, filtration fabrics. In this class we have studied some representative 4 examples of synthetic fiber material, how it is synthesized and what is the special applications. So, as a summary today class, synthesis of fibers, types of synthetic fibers, especially in 4 class of fiber we have seen, examples and properties of fibers, we have studied many properties, and manufacture of synthetic fibers, application of synthetic fiber we studied in details. So, questions of this today lecture: what are the synthetic fibers? I can name few. Raw material for the synthetic fibers, sources of the synthetic fibers, types of synthetic fibers and its availability, properties of synthetic fibers, what are the some property, physical or chemical properties, and applications of synthetic fiber can explain. So, within this we conclude today's lesson. Thank you.